Now, acetate, as one of the short-chain fatty acids, is the most abundant one that's released. In other words, acetate is the most populated within the colonic microflora. Now, this intermediary fermentation, those products actually include lactate, succinate, and pyruvate as well. And the fermentation of inulin and FOS, as I mentioned, will also produce these very high levels of lactic acid. Now, once these short-chain fatty acids are absorbed by the colonic cells, butyrate tends to serve as an energy source, while mostly acetate and propionate will pass into portal circulation. In other words, they're carried to the liver to be used for energy. And these short-chain fatty acids will then be metabolized by the liver as well as other peripheral tissues. And then, as we all know, the undesirable effects of the fermentation process would be the release of the gases, which are excreted through your breath, through flatulence, or in the stool. And just to bring to your attention, there's a very nice illustration on the fiber and prebiotics fact sheet, which is located on the Professional Services Internet site, and you'll find that under the heading of Miscellaneous Support Tools. The main effects of short-chain fatty acids are to increase bacterial mass, and literally what it does is add bulk because you're increasing the amount of bacteria in the fecal matter. They actually provide the colonic mucosal, so those cells that line the colon, a good energy source. They help to stimulate sodium chloride and water absorption, and that's because as you are pulling in or absorbing these short-chain fatty acids, you pull with them sodium chloride and water. There's also the stimulation of mucosal blood flow, so we're actually enhancing blood supply or perfusion to the tissues. And there's also the stimulation of mucus production. And because of the release of lactic acid, we're seeing a decrease in overall colonic pH. So there are many effects that we see from the use or production of short-chain fatty acids. So now let's focus on these prebiotics. What is the definition of a prebiotic? It's actually a non-digestible food ingredient that beneficially affects the host by selectively stimulating the growth or activity of one or a limited number of bacterial species that are already present in the colon. And ultimately what we're trying to accomplish is we're going to improve the host's health. And this is an actual definition that's been published by very common researchers in this area, and that would be Gibson and Robefroid. So next I'd like to talk about the bifidogenic effect. What is this, or this prebiotic effect? Well, what this means is to use these unique prebiotics, FOS and or inulin, to selectively promote the good bacteria that's already present in our GI tract, which would include lactobacillus and bifidobacteria. Ultimately, we're changing the environment because we're lowering the colonic pH, which then makes an environment that's much less favorable for those potentially pathogenic bacteria. That is what's referred to as the bifidogenic or prebiotic effect. And these are terms that you would commonly see in the available articles that we might provide to the customers. Now, I also would like to mention, because this question comes up a lot when I'm talking about the prebiotic effect, is how much of these prebiotics do we have to consume in order to see this prebiotic or bifidogenic effect? And there was a study by Buddington back in 1996, actually, that looked at the use of these prebiotics. And the outcome was that as little as 4 grams per day actually showed a significant increase in the bifidobacteria. So it doesn't take very much of these prebiotics to make a significant effect. And as most of you know, when you look at the majority of the Nestle products, a lot of them may provide close to or up to at least 4 grams per liter. Now, how are prebiotics defined? Well, they actually are under a category referred to as fructans. And these fructans are naturally occurring. So we get these prebiotics in our diets. And some of the common foods that we find these prebiotics in include wheat, artichoke, garlic, tomato, banana, and onion. These are just to name a few. And there's basically 2 types, if you will, of pure prebiotics. And that would be your inulin and then FOS. Again, that means fructooligosaccharides. So where do these unique prebiotics come from? Well, inulin is actually derived from the chicory root. And how this takes place is inulin is extracted using a hot water method. And the chicory root is literally that, it's a tuber. And these roots are washed and they actually obtain a semi-refined syrup that's purified to provide this nice powder type form to use in the manufacturing process. Now, fructooligosaccharides can be obtained in two ways. FOS can be extracted from inulin using a partial enzymatic hydrolysis. In other words, just breaking down inulin into a smaller chemical structure. Or FOS can be chemically processed. In other words, you can make FOS using sucrose. And if you look at the chemical structure of sucrose, that is glucose and fructose. And what these particular types of prebiotics mostly are many fructose polymers. So a bunch of fructose units, and then typically there is a terminal glucose unit attached. So when you look at the chemical structure of these unique prebiotics, it's very simple in a matter of speaking, but what makes them very unique is the bond that they have between, or the linkages between each of these molecules. And it's these linkages that can only be broken down by the good bacteria, or are preferred by the good bacteria in our GI tract. So that's what makes these particular short chain carbohydrates, if you will, so unique. And I'd like to share a quote by Roberfreud, again, a very well-known researcher in the area of prebiotics. And the comment is that currently food components that seem to exert the best prebiotic effects are your inulin-type fructans. And the reason that I point this out is because we do have other manufacturers that are using products that they label as prebiotics. However, they're not inulin and FOS. They're actually hydrolyzed guar gum, for example, which would be the Benefiber product. So that may have those prebiotic effects, as I mentioned earlier. However, because it's a much longer chain of these fructose molecules, it would typically take a lot larger amount to see this prebiotic effect. So just as fiber is not created equal, prebiotics are not necessarily created equal as well. And you can find some additional information in the Today's Dietitian article reprint that is available through ServiceLink. It does a nice job reviewing the benefits and the roles of inulin and fructooligosaccharides as well. So what are the benefits as far as these short chain soluble fibers? So in other words, inulin and FOS, because there is some differences found between the two. For example, your fructooligosaccharides have a DP, which stands for degree of polymerization. This basically means the chain length, the number of molecules that make up this particular prebiotic. And that is between 2 to 8. So roughly, on average, fructooligosaccharides are going to be anywhere from 2 to 8 molecules. Because it's a shorter chain length, it's going to be fermented or broken down by the existing bacteria more quickly compared to inulin. And because it's a shorter chain and has faster fermentation, it's going to support more of the proximal area of the colon. So it's going to support the beginning of the colon where it's fermented and feeding literally the good bacteria. Now, if we compare that to inulin, which has a chain length or degree of polymerization of 2 to 60, it's going to be longer in chemical structure, and therefore it's going to be slower as far as the fermentation process takes place. And what that means is it's actually going to travel farther through the colon and actually support more of the distal or towards the end of the colon area. So those are some of the key differences between the two. So when you think about the Nestle Prebio 1, that's a huge advantage to combine both FOS and inulin, because you're going to have the opportunity to support not only the proximal area of the colon, but also the distal area. So in other words, you can maximize the surface area throughout the colon with the added value or potential benefits of these unique prebiotics.